The next thing we are going to do is that lattice. Okay, lattice point, lattice, unit cell. The three terms we are going to do today itself. Okay, then if this concept is clear, then we can move forward with the further detail. Yes. Yes, what happened?
Sir, तुम्हारा mic muted.
Okay, so we are going to now you can listen, right? Am I audible?
Yes, sir.
Yes. Okay.
Yes, sir.
So we are going to do today. We are going to do at least three terms, three terms only. And this concept, if it is clear, then we can move forward in the next day, and that can be done very fast. That's not an issue. The first thing is lattice point. Please understand it. Lattice point. I'm just going to tell these terms. Lattice point, then lattice, and then unit cell. Unit cell. These are the three terms we are going to complete today. Okay, we must understand it. We must understand it today. Okay, that's the intention. Fine. Now, a solid substance. A solid substance. The particles are there. Obviously, we are talking of the crystalline solids now. We are talking of the crystalline solids now. Okay, that means they are uniformly arranged. Now, the particles are there. It can be the atoms, it can be the ions, it can be the molecules, or whatever are the particles are there. Okay. Now these particles are arranged, right? Obviously, solid means we have to understand it three-dimensionally. But to understand it three-dimensionally, first of all, we must understand it one dimension. All of you have the idea of one dimension, two dimension, and three dimension. One dimension means one axis, one line, right? Okay. Two dimension means a plane, two axis, x axis, y axis, a plane. Suppose this board is two dimension, and three dimension, all of you understand, but it's three dimension. Okay. So first we will understand, as I told, visualization is the most important thing. If I just go and tell and finish the thing like that, it is not going to help you out afterwards. Okay. Now, what is lattice point? First thing, what is lattice point? The particles, until now I am talking of that as the particles. The particles, whatever the particles, ions, atoms, molecules, present in the crystalline solid, are called lattice points. Simple. Lattice points are nothing. Suppose sodium chloride crystal. I am just taking sodium chloride crystal. Okay. So this is sodium ion. This is sodium ion. This is chloride ion. This is sodium ion. I am just keeping some gap, though they are very tightly packed. I am just keeping the gap for your understanding. This is chloride ion. This is sodium ion. This is chloride ion. Like that, they are uniformly arranged, right? Throughout the solid. And I had just drawn one line of it. I had just shown you one-dimensional arrangement of it. Each ions over here, each particles over here, chahe sodium ion ho, chahe chloride ion ho, are called the lattice points. These are nothing. Lattice points are what? These are the constituent particles present in the crystalline solid. Crystalline solid का जो particle होता है, उसको हम लोग lattice point बोलता है और कुछ नहीं. Okay? Amorphous solids को जो particles है, उसको हम लोग lattice point नहीं बोलते हैं. सिर्फ crystalline solids का particles को हम लोग lattice point बोलते हैं. Nothing. It's just a term which are nothing but the constituent particles. It can be the ions, it can be the atoms, it can be the molecules. Okay? I'll call lattice points. Now, what is lattice? I'll come to that. But before that, hope you understood this one-dimensional arrangement. Okay. Now I'm going to draw the two-dimensional arrangement. Two-dimensional arrangement means now on the plane of the board, how they are arranged. It's not only sodium chloride is here only, right? Sodium chloride is in this side also, and towards you also, in this side also. Actually, it is three-dimensional, right? The crystal is three-dimensional, but we must understand it slowly. Two-dimensional. Now, obviously, here there will be chloride ion. Here there will be sodium ion, because after sodium chloride will be there, right? They are uniformly arranged. Chloride के बाद में sodium है, then again chloride है, again sodium है, again chloride है, Okay, again sodium है. Like that they are arranged. And same way we can draw the other lines also. 1 line, 2 line, 3 line, 4 line, 5 line, 6 line, whatever. These lines together, so suppose again what will happen? Again the repetition of this will happen. Na positive, Cl negative, Na positive, Cl negative, Na positive, Cl negative. I just took the example of this. That does not mean that only sodium chloride is there. Just took the example for your understanding. So is this a two-dimensional arrangement of the lattice points? Is this the two-dimensional arrangement of the lattice points? You tell me first. That's the two-dimensional arrangement of the lattice points. Okay. Now we'll think of. Now you have to think. You have to visualize the three-dimensional arrangement. One more layer is here. It's very tough for you to see my three dimensions. Shreya is sitting over here. She can see. Three dimensional means बोर्ड का थोड़ा आगे. बोर्ड का थोड़ा आगे एक और लेयर है. यहाँ पे सोडियम के यहाँ पे क्या होगा? क्लोराइड होगा. क्लोराइड के यहाँ पे क्या होगा? सोडियम होगा. And so on. Another layer is there. उसके पहले फिर एक लेयर है, उसके बाद फिर एक लेयर है, ऐसे करके करके है layers है. Layers are there. Yes, that's the complete three-dimensional arrangement of the lattice points. Yes, this three-dimensional arrangement of the lattice points. This three-dimensional arrangement of the lattice points in a crystalline solid is called the lattice, or we also call it 3D lattice. 3D lattice कुछ नहीं है बेटा, अगर समझ जाएंगे तो कुछ नहीं है. Lattice point क्या है? What is lattice point? It's the constituent particles present in the solid, right? The constituent particles present in the solid. Okay, and how they are arranged? Obviously they are arranged in three dimension. To make you understand that I am telling first one dimension, then two dimension, and then three dimension. Actually they are present in three dimension. Now you must visualize the three dimensional thing. Okay, is it clear? So three dimensionally they are arranged. Fine. Okay, now this three dimensional arrangement of the lattice points, ये lattice point जो three dimensionally arranged है, इसको हम लोग बोलते हैं lattice. इसको हम लोग बोलते हैं lattice. Is it clear? Okay. Now next is the unit cell. Next is the unit cell. Please try to understand this. Now this is one square. Yes, this is one square. You can understand that this is one square. Just in front of this, what is there? Another chloride is there. Yes, another sodium is there. Another chloride is there here. Here another sodium is there. Is forming what? Forming a cube. Is it forming a cube? Did you understand that? Please visualize it as I told. Okay, is it forming a cube? Just forget about the complete thing. Just think of this. Is it forming a cube? Yes or not? I'm trying to draw that cube. I'm just trying to draw that cube. Okay, so there is a cube you can see. What is that cube actually? This cube is like this. This cube is like this. Okay, where I hope all of you understood this. Where this is what? This is sodium positive. Yes or not? This is okay. I'm just making it different color. This is sodium positive. Okay. This is chloride negative. This is chloride negative. Yes. Okay. This is again chloride negative. Yes or not? Just front chloride negative. Then this one is chloride negative. Did you understand what I am doing? This is chloride negative. Then this is sodium positive and this is sodium positive. So this will be chloride negative. This will be chloride negative. Yes. Yes. And the remaining ones will be what? The remaining ones will be sodium positive. Means this is sodium positive. This is sodium positive. This is sodium positive. And this is sodium positive. Just think of this first. First just visualize it. Is it that small cube? The first cube. Is it the first cube? First small cube. Did you understand that? If I consider this as a cube, is it that cube? Sodium positive, chloride negative, sodium positive, chloride negative, sodium positive, chloride negative. They are all in the alternate positions. Yes, that is the cube. Now just think of this cube. You are thinking of a cube. Now think of the total arrangement, total three-dimensional arrangement. Now if this cube is repeated, for several times in this direction, and this direction, in all three directions. Will you get the whole solid or not? Will you get the whole crystalline solid or not? So is this the smallest part of the crystalline solid? Is this the smallest part of the crystalline solid which is arranged, if it is arranged in all directions, all three directions, we are going to get the lattice of the solid, 3D lattice of the solid. This small part, this small cube, okay, obviously this is made up of what? This is made up of lattice points. This is made up of what? This is made up of lattice points only, okay, is called unit cell. Unit cell. So repetition of unit cell in all three directions is giving you what? Is giving you the crystalline solid. Just think of, I know all of you have seen it, all of you have played with it. I'm just it has come in my mind by seeing this diagram. That is why I'm telling. Suppose Rubik cube. All of you have played with the Rubik cube. Yes? As a whole, that's a cube. But in that cube, there are small cubes are there. Yes or not? So many small cubes are there. And that small cubes are repeated in all directions to give you the whole cube. Yes? The whole cube is what? The whole cube, whole Rubik cube is the lattice. That's the three-dimensional lattice. And the small cubes are what? The small cubes are nothing but the unit cells. And how these unit cells are made up? These unit cells are made with the constituent particles, whatever particles are there. Okay, it can be ion, it can be molecule, whatever. It can be atom, whatever it is. They are made up of constituent particles. So what is unit cell? Tell me now, what is unit cell? It is the smallest part of the crystalline solid. Okay, smallest three-dimensional part of the crystalline solid, which is repeated in all three directions to give us the complete crystal or complete lattice. Clear? Okay. Now unit cells can be of 14 types. Unit cells can be, here I have drawn only cube, right? It is not necessarily that it has to be cube. It can have 14 different unit cells. There can be 14 different unit cells by which we can explain the structure of any crystalline solids. Any crystalline solid का structure हम लोग इससे draw कर सकते हैं. Okay, इससे explain कर सकते हैं. But how these unit cells are varying from each other? What about the cube? Cube means we know that the sides are same and the angle is 90. Okay. Now if I just vary the angle from 90 to some other angle, will it be rhomboid? What do you call it? Rhomboid, right? Rhombus is 2 dimension. Okay. So 3-dimensional thing is called rhomboid. Okay. 3-dimensional rhombus means it will be rhomboid. So how are they varying? Their sides are same only. But what will be the angle? The angle is not 90 degree now. Angle is not 90 degree now. If the sides differ, then that can be also another unit cell. So how are they varying from each other? They are varying from each other either by sides or by angles. Either by sides or by angles. Their shapes are different. The shapes are different and they are varying either by sides or by angles. You don't have to remember any name, any side excepting the cubic one. Only cubic one you know. You can see the list that's there in your note, in your book. Okay, you can see the list, no issues. But you don't have to remember them at all. But what you have to know that there are 14 unit cells. There are 14 unit cells by which we can start. We can explain all crystalline solids. And this set of 14 unit cells, are called Bravais lattice. Are called Bravais. That's a scientist who did it actually. Bravais lattice. Okay, Bravais lattice. Okay, Bravais set of lattice. Okay, or Bravais set of unit cell. Okay, by which we can always, we can just explain all the crystalline structures. Fine. Now, one more point about crystalline solids. About the unit cell I will say. So hopefully these 3 terms is clear. Lattice point, lattice, and unit cell. You understood that. Okay. So lattice points are nothing. These are, again I am saying it. Lattice points are nothing. These are the constituent particles. Lattice is what? Is the 3-dimensional arrangement of the constituent particles. That is lattice in the crystalline solid. And what is unit cell? Is the 3-dimensional smallest arrangement which is repeated in all 3 directions to give you the unit cell. I give you the complete crystal. Okay, give you the structure of the complete crystal. That is unit cell. and the unit cell is made up of what? Made up of constituent particles. Okay, whatever particles are there, and there can be 14 types of unit cell by which we can explain any one of the crystals. Okay, and that set of 14 unit cells is called Bravais lattices or Bravais unit cell. Okay, Bravais is the name of the scientist, as we know. Is it clear? Okay, now unit cells can be of two types. Broadly can be of two types. I'm just drawing it, you can understand that. Unit cells can be of two types. One is this. One is, suppose I'm drawing a cube. As only cube is there, I'm just drawing the cube. And suppose the lattice points are present here. Just suppose I'm just drawing the surface sphere or circles over here. The lattice points are present here. Okay, please notice it and visualize it as I told. Where the lattice points are present? Lattice points are present only at the corners. Okay, if the lattice points are present only at the corners of a unit cell, then that unit cell is called primitive unit cell. Okay, primitive unit cell. Primitive unit cell means the lattice points are present only at the corner of the unit cell. But suppose if the lattice point is also present here, somewhere else along with the corner, बीच में है ये रूम को, in whichever room you are sitting, just think that as a lattice point. Think that as a unit cell. Okay, in the 8 corners, कितना corner है? 8 corner है. 1 2 3 4 5 6 7 8 नीचे 8 corner में 8 ball है. Then that unit cell is called what? Is called primitive unit cell. Suppose the unit cell looks like this. 8 corner में 8 ball है और बीच में in the middle of the room there is 1 ball. Or anywhere else another ball is there. Or anywhere else more than 1 ball is there. More than 1 sphere is there. Okay, we will see slowly that where it can be. Then those unit cells are called, means along with corners somewhere else if the lattice point is present, those unit cells are called, suppose this one, are called centered unit cell. Centered unit cell. Okay, so unit cells can be of two types. What are the two types? Primitive. What is primitive? Primitive means the lattice points are present only at the corner of the unit cell. And centered unit cell. What is centered unit cell? Centered unit cell means along with the corner they are also present where? They are also present in the body. Wherever inside the body, edge में, face में, कहीं पे भी है, we will see that. Okay, that is called the centered unit cell. Now out of these 14 sets, that also you must know, out of this set of 14 unit cells there are two divisions, 7 and 7. 7 of them are primitive, and 7 of them are centered. That means there are actually 7 different structures. Structure सिर्फ 7 ही है. Okay, but the lattice points in those 7 structures are present either only at the corner or somewhere in between. Yes, there are 7 primitive cells, unit cells, and 7 centered unit cells in the Bravais lattice. Okay, now as I told, I am going to concentrate on the cubic unit cell. In our syllabus, mainly 3 types of cubic unit cell is there. I am just going to tell it and I am going to finish it because I don't want to go further today. Okay, so cubic unit cells, mainly 3 types of cubic unit cell we are going to do it. One is already I had drawn it over here. Where this is a primitive, right? Where they are present only in the corners of the unit cell. That is called simple cubic. Okay, simple cubic. Fine. The other one, the second one, please understand it. It's very simple. Again, visualize it. Think your room wherever you are sitting as the cube. And visualize it. Okay. There is a cube. You are sitting in this room. Suppose there are lattice points at the corners. There are lattice point. All 8 corners there are lattice points. Okay. And there are lattice points at the face at the center of each face. एक क्यूब में आप रूम समझो, एक क्यूब में कितना फेस होता है? हाउ मेनी फेसेस? 1 2 3 4, 4 इधर हो गया, एक आपका रूफ, एक आपका फ्लोर, राइट? सो टोटल हाउ मेनी फेसेस? 6 faces. I hope all can visualize. There are 6 faces in a cube. Okay? Face का सेंटर में. Suppose this face where the board is there. Okay? This face का सेंटर कहाँ है? यहाँ पे है. So यहाँ पे एक बॉल है. कॉर्नर पे तो है ही है. बाकी सब फेस का सेंटर में एक एक बॉल है. So I am going to draw it. This is one face, top face. इसका सेंटर में एक बॉल है. एक लैटिस पॉइंट है. Okay? This is one face, इसका सेंटर का फेस में एक है. This is one face, bottom one, इसका सेंटर का फेस में एक है. This side one, इसका सेंटर का फेस में एक है. This is the front one, this is the front one का सेंटर में एक तो है. This is the back one का सेंटर में एक तो है. Did you understand that? Did you understand that? Yes, if the unit cell is like this, where the lattice points are present at the corners as well as at the center of the faces, then we call it face-centered cubic unit cell. Face-centered cubic unit cell, or in short, we call them FCC. FCC unit cell, face-centered cubic unit cell, or we also call them FCC unit cell. Okay, fine. As I told, 3 main types. These are 2 main types. The third one is, again, you think of a room. 8 corners, 8 are there. 8 corners, 8 are there. And one is at the center of your room here. One is at the center of your room. At the center of the room. Clear? Suppose this one only I am drawing over here only. Okay. So 8 corners, 8 are there, and one is present at the middle of the room. At the middle of the room. At the center of the room. One lattice point is present at the center of the room. Okay. If it is like this, then we call it. Then this type of unit cell is called. Body-centered. From the word itself you can understand that. Body-centered cubic unit cell. Body-centered cubic unit cell. And we represent, we also call it BCC. Body-centered cubic unit cell. So mainly 3 types of unit cell, cubic unit cell. What are these? One is simple. Simple means what? Which is primitive. Primitive means in 8 corners, 8 lattice points are there. The second one is what? The second one is face-centered. What is face-centered?